in ColorForce and in the RTX 2000 simulator. Let's go for a high-level view of things again. So let's see. I share the screen and let's see. These are my slides. I will talk about need words and define source libraries. And let's see what this is all about. First, I have to talk a little bit about abstraction. And that's something that is not so usual with Forth programmers that go down to the bits and bytes and think that the things they see there are the ultimate truth, which they are. Yeah. But sometimes it's good to have some bird view of things. And we will talk about what the technical way to do so actually is. And then we will apply this to a word that I want to propose, and that's the word need. We already saw earlier with spectrum next, we saw needs in action. And need is very similar in that it assures that a word is loaded. And needs, we discussed names, and needs is actually used in different Forth systems in a different way, but need seems to be available. So we go for need, and we will see how this works. And then we talk about some implementations that implement need. And so that's the need words part. And then we have the define source library part. How can we define libraries that others can use in a way that is good documenting and helpful, also following the idea of abstraction that we will see in a moment. And then let's discuss these things. So what is abstraction actually? So if you write an application program, the idea of abstraction is to hide the implementation details of libraries that you might use. What you get is some kind of interface that describes how the words or how the library functions are actually used. And this builds up some kind of idea of what is going on. So you create things that you know at an abstract level, and you operate on them with the operations that some library provides. And what things are there and what operations are necessary are defined in an interface. So, and all you need to know from an application program is what are the things and what are the operations you can use and you can work on with these things. And then there might be different implementations that provide the interface and the appropriate functions. And so that's the idea of abstractions. You don't know about the implementation details. All you know is the interface, the abstract way to use it. And that's nice because there could be different implementations following different restrictions on your hardware, for example. So if you want to read data, then the interface might provide appropriate functions, but you don't know whether this is a flash file system, if it's a file system at all, or whether there's some communication that reads the data from abroad or whatever. All you need to know is I want to open a data resource and then I read some data from it. Very similar to what Cornelius just described with this interface between the simulator and the host system. Yeah? You get some promise of how things behave, but you don't know exactly how things actually are implemented and carried out. So that's the idea. And let's put this into an action. What we want to provide is an interface to a source code. Yeah. So we don't tell you how you get the source code, but what you can say is need with a name. Yeah. So need -rot, for example. And then need assures that the appropriate definition is available after that. And possibly it loads some source code section from a library. And the library could be flash memory, or it could be a file system, or it could be the internet. We don't know, and we don't care. All we need to know is after we say need name, or need minus rod, for example, then we know minus rod as a function is available, as a word is available, and we can use it. If we say need assembler, then it loads the assembler program for the platform we're using. If we say need Z80 assembler or ARM assembler, then we load an appropriate ARM assembler so that we can do cross assembly. Yeah. If name happens to be defined already, then nothing happens. So because you want to nest need, and the sections that is loaded will contain other need occurrences, so that this is used recursively to load things. And if two sections require the same words, then you don't want to load them twice. So that's the reason why. And then you need to name somehow from where the library source code comes from. And so I use the word from for this, from with a library name. And so that selects the resource where you come, where need looks at to satisfy this. So need is the important thing, and from is just something that is used by me to do that. From is not a good name because other Forth systems use from for different purposes. Need is free, and if you remember anything from my talk, then it's the word need. And I want to, in future, structure all my source code like this. An application program just goes ahead and say what it needs by specifying need operations to make sure that all the appropriate source code is there. Right. So that's the interface, and there are different implementation of these source code library systems. And in 1995, I had a talk at Euroforce where I presented my simple source code library system. Use different words, use require for what we today call need, but require, again, is implemented in different systems in a different way. And there are systems that have like 4,000 or 6,000 words defined. So it's very hard to find actually a four-letter word that is still available. So I'm very happy with need. We heard also Albert van der Horst talking here in the Forth2020 Zoom meetings about CI Force and his want feature. And want is very similar. So you say want and a name, and then it loads from CI Force library the appropriate definition, very similar to what need says. The difference is that want parses all the words on the same line until the end of the line and needs all of them. And need just takes a single name, which is a more simple factor. Of course, Albert also has a factor wanted that takes a character address and a length string from the stack and does exactly what need does, a single load of a source code section. And very recently, Willem Overkerk in the NoForce implemented a Flash library where the source code is placed into the unused space of a Raspberry Pi Pico, where the Forth system is very small and occupies only fragments of the Flash, and the rest is available. And so he put system source code there, and his need then goes to appropriate sections in Flash and loads them on the fly, which is very convenient and very nice. Yeah. Remember earlier we before having need and the NoForce Flash library, these things were loaded via the serial line, and that is much slower, of course, than loading from Flash. So these are three different implementations of the need interface. So that's abstraction in place. Yeah. So if we want to exchange source code and the source code just says with need what it requires, what it needs, then either of these implementation would work. Yeah. So and the details of how to define the library wouldn't be that important. And so I encourage Forth implementers, implement the word need the way that I defined it in the interface, and then do a source code library implementation like you find most appropriate. So let's see, we continue. How would you define a section in my style? Yeah. I have a word desires, and that takes the appropriate context of what need actually specified, what is to be done, and then I specify the word that need looks for, and then I do conditional compilation. So this is how a section looks like. So if you say need minus rod, it eventually go to my library system, and in the end, come to this place, see desires minus rod. Aha, this is what need actually requested, and it will load that definition. And then it skips the rest of the library, so I can selectively load just this section. And I use standard conditional compilation words to do that. In Willem's implementation, it's way different. He uses binary markers and special search words for finding the appropriate section, but the idea is actually the same. Albert van der Horst uses blocks, and his wand actually figures out on which block the appropriate section is, and then he loads that block. Right. So that is what you can do. And then the question is, how can you manage the things that you write into these kinds of sections? How can I structure the library code appropriately? And there are small definitions like what we just saw, minus rod, which don't need any more structuring. But there are more difficult things like the assembler or some data structures that you defined that have in itself an interface of words that you want to use or that you want to expose to others to use, and those that are just used for internal representation or realization of the code. And the notion for that is we call these words external words, those that are supposed to be used by others, and internal words that are just used solely for realization. Internal words might change if you want to implement it in a different way or more efficient and whatsoever. It's implementation part, and what is external is actually an interface. Yeah, so it is a promise that these words will stay more or less unchanged, so that people can just go ahead and use them, and the implementation might change, but the way you use these words are stable. Yeah, and that is what unit is about. It's a way to structure things that go into these sections in the area of defining libraries. And again, unit is a four-letter word that is not used by Forth systems, as far as I know, and it's well matches what is done. Turbo Pascal uses unit, or Ball and Pascal at some later space uses it. How do you use it? You say unit, give it a name, and then you can do internal definitions that are just for realization, preparing something. Then eventually you come to external, can define part of the interface, words that you want to expose and that you want others to use. And then you can switch between internal, external as fits and as much and often as you want to. And in the end, you say end unit to close everything. This might or might not deal with search order. It's just an interface. And a dummy implementation will just make unit a very variable-like thing that just defines a word, and external, internal, and end unit are just no ops. So then you can load a code that is like this, and it doesn't do any search order manipulation. Another implementation would deal with this. NoForce, for example, has an inside vocabulary where all the internal definitions go in all of their tools. And then external would mean define something in Forth, and internal would mean define something in the inside vocabulary, or all the definitions that are internal definitions will go into the inside vocabulary. And end unit will just do nothing. So there are also for units different implementation. Unit itself is or the way you use it is an interface, how you structure libraries, and there are different implementations. In Volksforce, we have something like headerless words, where you could define temporary words, and eventually you can remove them from the dictionary, the names of them from the dictionary. And then external would be just normal definitions. Internal definitions will be headerless definitions that just have temporary names, and end unit will erase all the names that were temporary. So there are different implementations to do so. And that's the end of my story. I can tell you about my implementation of unit, internal, external, and end unit, but maybe the interface is fine and you just live with the interface and say, well, I can define dummy implementations, unit being variable, internal, external, end unit being no ops. And then you're ready for accepting source code that is structured like this. So to summarize, I talked about abstraction, hiding details of implementations, and there's a value in that because you can choose between different implementations that are specific to the environment that is used and can be more efficient in that environment. I propose to use the word need name in Forth source code, so to establish that name is actually defined, and leave open how this is accomplished. It could be source code loading of libraries the way I did it since 1995, or it could be loading of binary files if you want to, and so on. And it's an abstraction of source code management. And if you go for source code sections, then I would say it might be a good way to structure your code, distinguishing between internal and external words using the unit, internal, external, and unit syntax that I provide. Again, an interface, and there could be different implementations to do so. That's it. Thank you very much for listening, and I'm open for questions. John.
Yes, I was wondering how you handle conflicts with similarly named words from the source library versus the external.
Yeah. I handle these the way that you normally handle these with Forth also, because unit, internal, external, end unit works very well with vocabularies, and also need works very well with vocabularies or word lists. So if you have clashing names, then you have to put them into different vocabularies. That's something that is around need, unit, internal, external, end unit. Most systems will warn you if you do have name clashes, in that it gives you something isn't unique message or something like this. And if you see them, you have to be very careful of what's going on, and maybe put the needs in additional vocabulary. Or if your unit is actually implemented with vocabularies, you can also use unit to do that. Yeah, so that's something I don't take care of, and the environment has to supply this with additional means, but we know how to do that in Forth.
I have a remark.
Mm-hmm.
Originally, want was the same as need is now.
Yeah.
And once you use a small Ford, then you discover that you need a lot of things, but you can keep your Forth small. So, for example, I have a disassembler and assembler on top of, say, iForth with less than 400 words. But what I discovered is that neat is that then becomes unpractical, and that is what I have introduced. So I didn't like the lines for, like neat A, neat B, neat C, neat D, and dus I decided that loading a word at a time, that is pleasant, but you can use strings. But as a practical matter, I have introduced one, and then the rest of the lines are things that I want to have.
Yeah. Thank you very much for the explanation again, because I was wondering why Want actually does this. And I find this very beneficial because now we have need, which just takes a single token, and Want that takes the rest of the line. There's no name clash, so we can have both. That is quite nice. And it's quite easy to implement Want in terms of need. Because you have to parse the rest of the line and look at the tokens and then do whatever is necessary. Yeah, great. Thank you very much for the comment. Christian, you have questions.
Okay. Your presentation brought me back to a word called overlays in something that was probably some kind of Forth on Apple II. What's the relation between, why did it bring back the concept of overlay when you talked about your word need? Do you remember what overlays were?
I know what overlays are. I worked extensively with them. Then they were a means of saving memory because the main memory was so limited, and so you only had parts of the program in there. And then remove the code to load a different part of the program to work with that. That's actually a concept that you find, for example, in ColorForce, where you have the apps that are removed, and if you load the appropriate screen, just load part, and the rest is the other apps are discarded. But Neat doesn't have a notion of overlays at all. So it could possibly just add on top. There's no notion of an application or something that is removed if you say Neat.
So overlays were a kind of dynamic loading of binary code?
Yeah, I think so. Yeah. Yeah.
Okay.
Yeah. Go ahead.
I'll slip in another question. What's
Sure.
the relation with modules using Zeptoforth? Did you take a look at that?
Yeah, not exactly at the Zeptoforth things, but in VFX there are modules, and in SwiftForth there are packages, and in other Forth systems there are other module things. Actually, I think that unit is the most simple one. It strips away lots of features that others can do, like reopening a package or dealing with reloading of modules. That is something that is handled by Neat in this case. And so it's more an attempt of maybe we can find a common ground of using this. And it's not that you pick up the module system of another Forth system. That is not how the Forth community works. It's more my approach now to say, well, this is the interface. That's a word, and it's not specified how it's implemented, but only what the effect should be, the interface.
Okay, thank you.
Are there any other questions? Well, then thank you very much for listening, and maybe you consider implementing need or use need in your environment. So that would